notes then, the warm-up was just making sure you had your calculator and I had a certain setting. So we're going to learn about confidence intervals. Oh, I suppose I should hand out the new unit overview, huh?
Yeah.
You should take our old overview.
I should what? You know,
overview.
yeah, there are people who have scores for last unit's
I
homework.
don't know why. I was not here late last time. I just at no point did I see you walk around collecting homework.
More like you were talking.
To who?
I don't know. That's all I can figure. Where is it? How am I supposed to take it if you
Oh,
don't have
dude.
it out?
Oh, yeah.
Goodness gracious, maybe that was the issue. I walked around and you didn't have it out.
Okay. I have that.
Yeah.
Okay.
This math is too much math. It's like confidence. Like what is that? Like it's not actually it's not even math anymore. It's just random things.
So it's not true. This one's actually quite practical.
Confidence.
Confidence intervals.
I don't want to go through this. Yes.
I did like the last one.
2 days. No, no, one of those days.
Okay, so this is 7.3.
Do you think I could, if I threw it in the trash, I could get? Yes.
Oh, yes.
Last night you can't, and you did. I think they're just so much smaller. I can't,
That's
like,
ridiculous.
I can't see the trash. can.
These are all variables.
I'm gonna throw this in the trash. can.
Oh, yeah.
Or, yeah, or I'll hit you.
No, that's where's
That's close enough.
Yeah. This is bad boy.
I just got your switch.
Poop.
One purpose of my
Yep. That's not.
Did you ever go see Alex?
Literally, that's not the same. Scoopity, poopity, poopity, poop.
It's pointless. It's but I rolled it anyways, so the wrapping did that.
All right. Did I miss anybody with the new unit overview? So, like I said, we're going to learn confidence intervals. Today we're just going to get into the basic idea. Then next time we'll make a confidence interval by playing with Hershey Kisses. And then we'll get into confidence intervals for sample proportions and sample means. And then your test is Tuesday, February 28th. Tuesday.
It's not a great day to have this.
I'm very sorry.
Tuesdays are weird.
Yeah, of all the days of the week, they're the worst. Right?
Agreed, yeah.
Not Wednesday, really?
It's gotta be like Monday or Tuesday. Because you're like halfway
Or
through.
Tuesday,
It's like you're
Wednesday's a
not even,
bad day.
because like with Tuesday, it's not even halfway yet. It's like, you're like, you're not even close.
Okay. All right, you guys convinced me. Tuesday's the worst day. All right, so we're going to look at Unit 7 test scores from last year. I have not finished grading your Unit 7 tests yet.
That's okay.
Thank you. So we're gonna work with them from last year.
busy weekend too.
I need your ladies' calculators to check a setting, or you can just borrow one of mine. Will you hand me Maggie's?
Three times.
Poor guy.
Thank you, Miss Whittle. Thank you. Is mine good?
Yes. All right, so the Unit 7 test scores from last year follow an approximately normal distribution with an unknown mean and a standard deviation of 10. We're going to estimate the mean test score by taking a sample of, it says 4, I'm going to change it to 5 students. So what is our population in this situation?
You have people who took the Unit 7 test last year. Right?
Yes, thank you, ma'am. AP stats, Unit 7 test scores from last year. Are we working with the mean or the proportion? Mean or proportion?
Me.
Mean. It says mean right there. So, parameter, mean, what's our notation?
Pew.
Mu.
Oh, awkward.
What's our sample gonna be?
Huh?
What's our sample gonna be?
5 students.
5 students. And what notation will we use then? X bar.
Oh.
Alright, now I'm going to show you how to get your sample on your calculator. These are not buttons, a procedure that you have to memorize. This is just for the activity today.
Okay.
So we're just going to walk through it, but then it's not something that you need to know for your homework or the test. Everybody got their calculator on?
Yes, ma'am.
Thanks, Maggie. We're going to hit second stat.
Second stat.
And then you're going to go over to math. And you're going to choose mean, number 3. Hit enter. And it should put the mean with the parenthesis in the home screen. Then you're going to hit math. And you're going to go over to prob. And we're going to choose number 6, rand normal. Now if you have a newer one, it's going to prompt you for your mean, standard deviation, and sample size. If you do not have a new one, it does not prompt you, in which case you'll put the same stuff with commas in between. So our mean is unknown, so we're going to put M, which is alpha division. Alpha division, that gets the letter M. M for mean. Or M for Molly.
Or Maggie.
Or Maggie. Or, no, not Mason.
Yeah.
Are we good? And then our standard deviation is 10. And we're doing 5 students. So you guys need that, if you have an older calculator, M, comma, 10, comma, 5. And it should look like this at the end. And then, once you have that in there, hit enter. We are gonna get different numbers. We're taking different samples this size 5. So my X bar is 92.506.
Oh, was everybody a different thing?
Yes, everybody took a different sample of 5 students. What'd you get, Colton Morgan?
I got 81.64.
81.64. Mason?
What?
Oh,
What did I get? Oh,
Yeah.
78.44.
78.44. Ethan?
I got 82.46.
82.46. And let's go with Maggie.
I got 91.57.
Okay. So we all got different X bars. That's the idea behind this sample. We're all going to get different values. You're going to write the conclusion based on your X bar. I'm going to write mine based on my X bar. So you can write what I write. The only thing is your X bar should be whatever your X bar is. So we took a sample of 5 students. Based on my sample, I would say that the mean Unit 7 test score from last year is 92.506. You're going to have a different X bar in there. That's why we say based on my sample, because we each have different samples. I forgot the word mean, sorry. The mean unit 7 test score to be I really suck at English. I could have worded that so better, sorry. So better. That's not good English either, is it?
Didn't you let me skip English in college?
Yeah,
Just by
they
testing out
probably shouldn't have let me.
Just because why?
Because I didn't want to take it, so I challenged it. And they were like, yeah, you're right, you don't need to take English. And now I'm like, ooh, I probably should have. But I didn't have to write in college. It was so nice.
I think
All right.
I'm gonna try that.
So, like I said, first of all, I did really bad with my wording, so hopefully you worded it better. But for the most part, the only thing that should be different is your X bar versus my X bar. So that X bar that we use to estimate the parameter is called a point estimator in this chapter. And a point estimator is a statistic. Hi, DJ. That provides an estimate of a population parameter. Thank you. The value of that statistic from a sample is called a point estimate. I'm going to abbreviate point. And ideally, a point estimate is our best guess at the value of an unknown parameter. So, we took a bunch of samples, the size 5. Now we're going to create a sampling distribution,
I love
which
Claire.
is, you love Claire?
I do love Claire. She's awesome.
Claire is awesome.
Yeah.
I'm not so sure about the what I saw going on between you two, but we're going to draw our sampling distribution down below for all our samples the size 5. So, and change it so it says size 5 right there. So what would the shape of our sampling distribution be, and how do we know? Why?
Because you said it was approximately normal.
So I did say up here it's approximately normal, so our sampling distribution is going to be approximately normal down here as well.
Okay. Oh, that's for baby. Yes.
And then where's our center going to be? My pen is dying.
It's like a literal child.
What is the formula for finding the center of a sampling distribution for X bar? Mu of X bar equals mu. So our center is still going to be at mu because our statistics should estimate the parameter closely. And then what's our spread or our standard deviation? What was that formula? Sigma of X bar is equal to sigma divided by the square root of n. Thank you. What's sigma, our standard deviation for the population? 10. And then what's our sample size? So we're going to take 10 divided by the square root of 5. And what was your question, Brooke?
Never mind.
Okay.
No.
So we get 4.47-ish. And now we can make a beautiful picture. We're gonna draw our normal curve. Oh, that was not a good normal curve.
Better than most of us.
Yeah, but that's like one of the worst of mine. So it's normal with a mean of mu and a standard deviation of 4.47.
Oh, that.
I have
Am I sure what? Oh, sorry. All right, so at the center is mu. And then we're going to do mu plus 4.47, mu plus 2, 4.47, so mu plus 3.47.
We don't know mu, so it's just.
Yeah, we don't know mu yet. We're going to learn how to estimate mu. A different way, because we've already learned multiple ways to estimate mu.
Yes.
Yeah.
Just yes.
A whole last chapter was about estimating mu. Come on.
That's what
Why would you?
Whoa, that's where it found.
We're playing a game, Mason. Play along.
What situation? What's everything?
Lots. Most commonly, political polls use this pretty much every time.
Really?
Yes. Anytime you see a poll on the news, they're doing this. So even if you don't use it in whatever you do with your life, it is nice to know what they're showing you on the news. If you guys watch the news. Do you guys watch the news?
Nope.
No.
Sometimes.
Where do you get your news then?
So Apple just sends me newsworthy events on my phone.
And you just trust Apple to keep you in the loop. That's kind of scary. Do you not?
It's not relevant to me.
Well, it
Yeah.
shows you the news source it's from. Like, I trust ABC.
Okay.
I just live my happy little life.
What else knows is interesting.
You keep doing that, Brooke. The world is a scary place. Ignore the news.
Yeah, exactly. I just do my little tasks.
All right.
Usually I don't.
Are we good on how I labeled our curve?
I think so.
I just added and subtracted standard deviations. All right. I know it was my fault, Mason, for asking about the news, but we're going to refocus, okay? So 95% of all our X bar values will be within how many standard deviations of the mean?
Three.
Is that 3 or
It's 3.
get rid of a finger?
Isn't it 2?
It's 2. Remember that rule? 68 is within 1 standard deviation above and below. 68%. And then we have 95% within 2 standard deviations above and below, excuse me. No, not 98.
99.7.
99.7.
I forgot these values.
You don't ever forget these values, Mason. That hurts.
I can't believe you didn't show our moms.
99.7. All right. So 95% is within plus or minus 2 standard deviations of the population mean mu. We know that our standard deviation is 4.47, and when we multiplied that by 2, we added 8.94 and we subtracted 8.94. So when we add or subtract 8.94, that value is known as the margin of error.
And it's 2 standard deviations.
Yes, because we're looking at 95%. Now, what was your point estimator? Sorry, I said that weird. Point estimator for the mean.
Isn't that just what we got?
That was your X bar up above. So mine was 92.506. Yours is something else. And then what did we just find the margin of error to be? Plus or minus 8.94. So now we're going to create our first confidence interval. The very general formula for finding a confidence interval is your estimate plus or minus your margin of error. So we're going to make a 95% confidence interval. My estimate is 92.506. You have a different estimate. And I'm going to add and subtract 8.94 to that number. When we write our confidence interval, we write the smaller number first, then the bigger one. So I'm going to do subtraction first, 92.506 minus 8.94. We also write it just like a ordered pair. So in parentheses with a comma in between. And then when I add 8.94 to my estimate, I get 101.446. And I ran into the hole punch. I hate it when that happens. So you're going to have a different confidence interval from me because you had a different estimate. Now, we're going to interpret this interval. Let's go with green. When we interpret intervals, notice they're called confidence intervals. So we talk about how confident we are. So we're going to say something like, we are 95% confident that the interval, and then you give your interval. I'm going to give mine, that the interval 83.566 to 101.446 captures Are you okay, Bella?
Okay, I am.
Just take a 0.5 for
What did
Yeah,
you
we have to
get,
take a picture
Allie?
of you.
athlete of the week.
Oh, good job, Allie.
She's an extraordinary athlete.
She is an extraordinary athlete and an
Outside.
extraordinary student.
She is. And an extraordinary
Give me a
person.
applaud for Ellie.
Yes. All right, so we are 95% confident that the interval captures the true mean Unit 7 test score from last year.
Go, Ellie!
Thanks. I voted for you. You did? I voted for you too. I voted for you, dear. Oh.
So yours would be different with the interval. Notice we use the word true. You can use the word actual, but we talk about how we're confident it's capturing the true or actual mean. And then I put it into context, Unit 7 test score from last year. Now, that was for interpreting the confidence interval. In a minute, we're going to interpret a confidence level, and they are different. May I flip my paper over?
So what's up with statistics and making things basically the same thing?
I agree with this.
Yeah, like
I see what he's saying.
can they have a little bit more uniqueness in the names and all their stuff? I feel like everything's so confusing.
Yeah, I don't know what to say. I didn't get to choose the names.
Yeah, why'd you
So
make
I'm
it
sorry,
this way?
Mason. I do understand. I was going through the tests, and there was one question where it says, I can't remember exactly, but suppose the sampling distribution of the samples from the size 5 from the sample population, like samples showed up 6 times in a single sentence. And I thought of you, Mason. I was like, oh, this is why he gets angry at these questions.
Yeah, I was like, this is so hard.
Sorry. So, important note, when we interpret confidence intervals, you do not say that there's a 95% probability or a 95% chance of capturing the actual value of the parameter. We always say that we're 95% confident, or whatever percent confidence interval you're working with. But if you put probability or chance in your interpretation, you're going to get it wrong. We do not say that. This is not about probability and chance anymore.
It's about confidence.
It's about confidence.
Like
Ain't
So-
that the truth?
Just wait. I'm going to mess with your minds. Okay? So here we're going to interpret the confidence level. So I can ask you to do any type of confidence level. So far I've focused on 95%. So that's the confidence level that we're going to interpret. But I could ask you to do 98% confidence, 90%, 68%, 70. I could pick any percent between 0 and 100. Although I don't think I've ever seen it go below 68 because that wouldn't make any sense.
Yeah, what's the point?
Anywho, so there are lots of percents that I can ask you to do a confidence interval for. Right now, we're going to do 95% for our first interpretation of a level. So 95%, and that would change based on the level, of all possible samples of size n which in this case our n was 5. We took samples of size 5 from the same population. What is this sounding like? Sounding like the definition of a sampling distribution, right? All possible samples of the same size from the same population. Well, 95% of those samples will result in an interval that captures our unknown parameter.
How does the calculator make the estimation?
Did you just put A or D for an hour?
Yeah, I did. I told you I'm not good at English. I was thinking about Brooke's question. If I'm being honest, I'm gonna blame it on her. That's why I used the wrong R. That's what I did. I set it so it would all go around the same parameter. I set all your calculators to be similar. That's why it could take an estimate. All right, so if I asked you to make a 70% confidence interval, the only thing that would change is the percent. We'd say 70% of all possible samples, the size n from the same population, would actually capture our parameter. So what I'm going to have you guys do now, just for practice, is you're going to take 2 more samples of size 5 from the population and create your confidence intervals. So you're going to find a new point estimator and you're going to add and subtract the margin of error. Now, if you haven't cleared your calculator, you can just scroll back up and find that mean rand norm M105 and hit enter, and it'll put it back at the bottom for you, and then you don't have to go through all the steps. So I want you to find 2 more confidence intervals, get a new estimate, and add and subtract our margin of error.
So mean. How do you put norm in here?
This is not something
Not there. Nope.
It's just
Over there. There. 6. No. Go to prob. Prob. 6. Got then the M. Oh, that was B. Motherfucker. Okay. You need an app, see. What are those? No, you need like an app, see.
You have time to take a nap before practice.
Miss Whittle,
Whittle?
I'm supposed to go see Miss Berry.
No.
Is that allowed?
No.
Why do you need to see Miss Berry?
For the
No.
Why do you like her better than Miss Whittle?
I'm sorry.
You brought. Thank you.
Does everybody in the school like Miss Berry?
What? Did you just sorry?
She's still neat. Okay, what time would your kids
Well,
do
I
their homework?
look,
So she put
can
them
I show you
on
our
the
conversation?
table to do the homework.
I lied to Margaret and said that I couldn't go because I had a test.
It's a little
So I
funny,
wanted
but like
to
you
go.
can't do that.
Go to what?
I can do that as a student though. I love the
Miss
best
Whittle.
Will you go put that up there for me,
I
Mason?
love the benefits. Benefits of bowling.
Oh, yes.
There's something to do.
But how? You just do it again, and you just do the same thing you did 2 times. You add the.
Oh,
Yeah. Just down the middle school experience.
Does it still 95%?
Yeah.
What did you
Isn't it? Well, I just feel like it's
There you go.
Uh-huh. So much fun. 75. Find 2 more confidence intervals. Now add and subtract your margin of error.
Oh, God.
Uh-huh.
Plus,
It's not that.
8 point some
That good.
you're not anymore. Oh, so I only had 1 this morning. And I got into my car and I was like, well, I'm not gonna go back. So I'm just wearing the 1. It's like a fashion statement. You know,
All right, Mason gave us 2 more. He redid it and got an estimate of 87.2, added and subtracted 8.94, And then again 86.62 and subtracted 8.94, so we got 2 more confidence intervals. So now we're going to look at an applet to show you a little more visually what a confidence interval is doing. Oh, poopers. Sorry, I was typing. I can't speak and type in my password.
Your password's poopers?
No, I got mad because I was almost to the end of my password and mishit.
That'll get you.
My hotspot password's poo-poo.
What?
Okay.
What? My little brother's the only one who uses it, so it's an appropriate password.
That is appropriate. All right. So here's our applet. So we have our population, Mason. It is normal. The mean mu is at the center. The sampling distribution is the like brick red dotted part. Again, the sampling distribution, or excuse me, the mean is at the center. Over here I can change the confidence interval, but for now we're working with 95. And then our sample size, right now it's set to 20, but we're working with 5. Notice how when I did that, it spread out more, because when you increase your sample size, you decrease variability.
Yes.
So when I decreased my sample size, my variability increased. So we're going to take a sample, and it's going to create a confidence interval for us, and I feel like I'm going to sneeze. All right, there's our sample. The yellow dots below are the 5 actual pieces of data. This dot here is our point estimator, and then it found the margin of error and subtracted and added. So this would be the lower bound and the upper bound of the confidence interval. So like when Mason came up here and put these intervals, the 87.2 is that big dot at the center of the line. And then the 78.26 would be down here at this end. And then the 96.14 goes off to the other side. So it has all 3 parts of our confidence interval. The estimate is the dot at the center. Then when you subtract your margin of error, that's what gets you down to the left side. And when you add the margin of error, that gets you up to the right. So we talked about how the confidence level tells us 95% of all possible samples, the size 5 from the same population, will capture our true mean. So notice that the mean is in this confidence interval. The interval and the green line intersect. So if I take another sample, here's the 5 individual points and then our confidence interval. And I take another one, and I can take a bunch of samples the size 5.
What does it mean when it's red?
What does it mean when it's red?
Outlier.
Look, it didn't capture our mean, did it?
No, it sucks.
So it's red to show us that the mean is not in the interval. And over here, I've taken 14 samples the size 5. Out of those 14, 13 captured the actual mean, which is 93%. So as I take more and more, this percent hit is going to get closer and closer to 95 until it's going to stay at 95. That's what 95% confidence means. Is that if I take more and more, 95% of them actually capture that mean. So, down below, we're going to play a prediction game. I'm going to change the confidence level to 80%. what do you think that's going to do to the length of our interval? If I go from 95% confidence to 80% confidence, do you think the interval is going to get longer or shorter? Why shorter? Because it's less. It is less. If we look back here, 68% is 1 standard deviation above and below. 95 is 2 above and below. So 80's in between the two, so our interval gets shorter. What's going to happen to the percent of the intervals that actually capture my parameter? Colton? What's going to happen to the percent that actually capture the parameter? I do know what it's going to do.
So tell us.
But I wanted to see if you were listening.
I will.
Listen, Colton. So, Colton, 95% confidence interval. The percent hit was the amount that captured the true mean.
Right.
And it levels out at 95% the more and more I take. So the more and more samples I take of 80% confidence, percent hit is going to level out at what? 80. This is going to go to 80. That is what you said on your second try. I'll give you that. All right, so let's see if I misled Colton. Wouldn't that be funny if I misled Colton, didn't actually go to 80? All right, I'm going to reset it. Actually, hold on. There's a 95% confidence interval. We're going to change it to 80. So like you guys predicted, our interval actually gets shorter. And then if I take more and more, our percent hit does level out at 80%. So from 80%, if I change the confidence interval to 90%, is our interval going to get shorter or longer? Longer. And what's going to happen to the percent hit? It's going to go to 90. So if I take the confidence level and I change it to 90, we can see that they are getting longer. And then if we look at our percent hit, it's getting closer and closer to 90. It's not quite there yet. Oh man, oh, there we go.
Will we have to make graphs like this? Oh, I skipped one.
Yes.
No.
Okay.
Not like this on the board, no.
Oh, okay.
No.
I was thinking no
No.
way I have to.
All right, what's going to happen if I change the confidence level to 99%? Is my interval going to get longer or shorter? And what's going to happen to the percent hit?
99%.
Oh, it might help if I hit the button. I was just going to change it without changing that. All right, so 99%, those intervals are getting bigger. And look, the percent hit, that time I don't have to take any more samples. It is 99. All right, anybody notice anything weird about that?
Looks weird.
Well, yeah, it looks weird.
The red one's just goofy.
Okay, the red one's goofy. I guess I kind of opened myself up for these kind of comments, huh? How do we make these intervals longer?
Increasing the confidence level.
And when we increase the confidence level, what are we doing to the margin of error? We're increasing it. Yeah, isn't that weird? The more confident we get, the bigger our margin of error is. So that right there is how statistics lies all the time, right? Because as we increase our confidence we're actually creating more error in our math. So down here, I'm going to come back to this part, but down here, that's what we just talked about. As the confidence level increases, the length of the confidence interval increased because our margin of error also increased. So these three questions show that. That is, we increase our confidence level, we increase the length of the intervals, and the only way to increase the length of the intervals is to increase our margin of error. Now, in the middle here, I told you this is the general formula for confidence interval. You take your estimate plus or minus a margin of error. We can get a little more specific. If we want a 68% confidence interval, I'm going to take my estimate, which is x bar for now, and I'm going to add or subtract one standard deviation, because 68% of the data is between one standard deviation above and below. We focused on 95% today. We took our estimate and we added and subtracted two standard deviations. I could even ask you to do a 99.7, and we would add and subtract three standard deviations. Now those three questions right above that, did I use 68, 95, or 99.7? No, I used 80, I used 90, and I used 99. Like I said, I can ask for pretty much any percent, although I said I don't think we'd go below 68. To find any percent, we're going to learn how to find a value called T star. And it literally is a T with a star, an asterisk next to it. It's called T star. And we're going to add and subtract T star, number of standard deviations. So this is T star, also known as the critical value, which I will teach you how to find, not today, but later in the unit. And that allows us to work with percentages that aren't perfect standard deviations above or below. All right, so we talked about how if we increase confidence, we're increasing our margin of error. So we can decrease our confidence to reduce the margin of error. But what's another way we could reduce margin of error?
Increase trials. Or not trials, the sample size. That's what I'm
Increase
trying to
sample
say.
size. Thank you, Brooke.
The standard deviation smaller.
If we increase our sample size, we make standard deviation smaller, which margin of error comes from your standard deviation. So if you decrease your standard deviation, you're going to decrease your margin of error. And by the way, margin of error, you will see abbreviated as ME. Both capitals. Me. Oops, sorry. And then your exit task is interpreting an interval, and interpreting a confidence level, and then a true or false. So you should be able to do all three of them without my help. Just refer to your notes. And now, Colt Morgan, you may go see Miss Barry. Thank you for waiting, sir.
One time, Miss Mary, yelled at me because I didn't pass the leave for
Just think, guys. I could have been streamed
She told me to go,